Hello, my name's Richard Fischer, and I'm the publisher of xyHt, Inside GNSS, and Inside Unmanned Systems magazine. I am here with Steve Woolven, president of Trimble Applanix. Thank you, Steve, for making the time. Welcome.
Thank you very much, Richard.
I appreciate you having an opportunity to talk with me today. Steve and I have been having conversations about positioning, navigation, and mobile mapping for a lot of years now. And what makes this kind of current moment in time really interesting is how fast the industry and the jobs of the people working in it is changing underneath it. So whether you're mapping from an aircraft, a vehicle, a vessel, or even an autonomous platform, you're being asked to do more things now. And what is that? You're being asked to collect more data, cover more ground, turn that data into actionable intelligence, and to do so faster. And oh, by the way, with more complexity in the field. So the requirements seem to be, the bar seems to be raising. The requirements are kind of getting more intense. But at the same time, sensor fusion, GNSS, inertial, corrections, cloud processing, and autonomy are changing what direct georeferencing can actually do. So rather than have a series of questions for Steve, as this was billed, this is live and unfiltered, and we're just going to have a discussion. I've had many of discussions and interviews with Steve over the years, and we get to some really interesting places. And now we're inviting you all into those discussions that we're normally having in private. So we welcome everybody and appreciate your time and attention. But before I start, I want you to know that we're going to have a series of poll questions, 3 poll questions, in fact, which are in your chat. We'd sure appreciate it if you would provide your feedback. We appreciate that feedback loop. So I encourage you to answer those poll questions as you are able. And by the way, the poll will close at the bottom of the hour. I'll give you a reminder a little bit later. So Steve, let's jump in. So across, aerial mapping, mobile mapping, marine, customers are being asked to capture more information, cover larger areas, deliver faster results, but nobody's given them permission to sacrifice accuracy. What has changed most in what customers are asking Applanix to help them solve?
I think there's 2 elements to that. One, you've hit it right on the head. I mean, accuracy. Accuracy is paramount. Trust in that accuracy is paramount. We'll come back to that in a little bit.
Okay.
The amount of data that customers are collecting now is so much more than it was 10 years ago, 5 years ago, 2 years ago. Customers are asking, how can I handle all this data? How can I process all this data? How do I know that the answer coming out at the other end is the best answer I can get at the time? It is becoming more and more challenging for their businesses because they're under more time pressure. They need to deliver actionable insights, not just what used to be hard disks full of data anymore. They need to deliver the insights that the customers are looking for. So they're under tremendous pressure to collect the data, collect it correctly, collect it once. When they go to process the data, they can process it with confidence. They can process it quickly, get the information they need out of that data, and then be able to deliver that to the customer.
Yeah, and essentially what you're saying is there's a real focus on workflow.
Absolutely.
People do not, contractors, surveyors, geospatial, mobile mapping professionals, they themselves don't monetize the inertial integration or the accuracy or the precision necessarily. They monetize that workflow. So to the extent you are, providing value, benefit, precision, confidence, integrity, a word we'll get to later, that benefit is creating better quality, more reliable workflows.
That's right. That's right.
And that's what they rely on.
And I think, if you take a step back 10, 15 years ago, a lot of the customers were interested in building their own sort of systems because they wanted something a little bit unique. Seen a real change in that over the last 5+ years. in customers really want to focus on what they do best. Whether it's delivering aerial data or
Sure.
hydrographic mapping, they don't really want to care about how the equipment works, but they need to know that it works.
Yeah.
And so that's been a real shift in the last 5 to less than 10 years.
Yeah, and for in the early days of direct georeferencing, Applanix was an early pioneer in direct georeferencing, and what that technically makes possible. Today, though, we're talking about what pain points, what complexity can be eliminated from the workflow, as you said, and what are those things that how are you helping take complexity out of that workflow? I mean, is it fewer ground control points? Is it eliminating reflight? And how are the benefit of simplifying and improving the workflow? How does that express itself to your customers?
So I think the answer is yes, and yes.
Okay.
The industry's been changing a lot over the years. If you read some of the statistics online now, it says that in North America, over half of the surveyors are over 50. Some stats put that at over half, over 60.
That may be a generous characterization.
It could be.
Yeah.
Another stat says that for every 1,000 surveyors that retire, only 500 come back into the business. So the systems which are very complex and traditionally have been a little bit more difficult to use. In some cases, you need a higher level of training, perhaps a higher level of understanding. There were more, knobs and switches, bells and whistles.
Right.
The real push has been to use the technology, use the processing power, use the concept of sensor fusion to be able to make it simple. Can we get it down to a simple push button?
Got it.
Green go, red stop, and so that the people actually collecting the data, executing the project, need to know far less about the data they've collected. Again, you still need to set up the environment correctly.
Right.
But they can be much more confident that the data coming out is correct without having to have a PhD to actually do the processing.
Got it. So you mentioned sensor fusion, which is something that we've covered in all our media and journals for 25 plus years. And it's been fascinating because the level of complexity is continually increasing. So you have two kind of contradictory and in some instances conflicting objectives. You want to simplify the complexity, yet at the same time, the sensor integration is becoming increasingly complex. Why? In the service of precision, accuracy, and integrity.
Right.
That word we'll get to the third time we mention it. And so, sensor fusion is everywhere. And you're making the point that customers don't really want to know about it if they don't have to, because if you eliminate those pain points, they can go about and their business and do the things that they are expert at. That gives them more time. It's far more efficient, creates a more productive kind of value chain and engineering chain. But what distinguishes sensor fusion from simply putting together GNSS, an inertial measurement unit, cameras, LiDAR, and some corrections? Can you talk about how you try to simplify the sensor fusion as it becomes more and more complicated?
Sensor fusion is a very broad term.
Indeed.
And yes, you can just put sensors together, have some sort of algorithm to bring the data together and call it sensor fusion. That wouldn't be incorrect.
Right.
I think something that Trimble has always been from day one very mindful of is back to this integrity concept.
Mm-hmm.
You've got all these data flows coming in, and the further we get, forward in time, the more sensors we're adding. We had GPS at one point.
Sure.
Inertial's been around a long, long time.
Yep.
And we got the whole GNSS concept. Now we're integrating camera workflows. We're integrating LiDAR workflows. We have other sensors coming online here shortly. We'll talk about in a little bit. All of that adds to the complexity of how your sensor fusion engine has to work.
Indeed.
making sure that that data is critically time aligned, so you know when the data is good. And that's the other element is filtering out the data when it's bad. You now have so much additional data to help filter out bad data, or GNSS or LiDAR points, whatever it happened to be, that you can actually, with the processing power on board now, create a much more intelligent sensor fusion engine, which from the engineering team developing it is very complex.
Sure.
But from the outside looking in, it just works.
Yeah.
And that really is what the customers want. They want to know how to go fly, how to go collect the data. They want to know that the data they've captured is good or not. And then they want to know that information that they're going to extract from that data is valid data.
Indeed.
And then as we get into the workflow, which we'll talk about, is how do you keep the integrity of that data through the workflow?
Yeah, and that's word, there it is. It's the third time now. So I feel compelled to actually define the terms. Being a journalist and a publisher, we language we have to be very careful about. But integrity is the measure of trust that can be placed in the correctness of the information supplied by the navigation system. With this caveat, and you made this point, including its ability to warn the user promptly when the information ought not to be used. And that's, the concept of graceful degradation. And we're living in a world in which we're seeing increasingly complex operational environments. And I'm being very polite when I say that, whether we're talking about, wars or geopolitical considerations. There is jamming and spoofing going on. There is a highly dense, almost saturated electronic warfare environment, and depending on where you're doing your work, and there's a lot of leakage in this, and so the concept of integrity and your ability to trust that position output is becoming, really far more critical. It was always there, whether it's safety of life considerations, mission critical, safety critical. But the reality is now we're seeing evidence almost daily of what happens, when those principles aren't adhered to. And so I just think that, which is why we really want to define the concept of integrity and just how important that is, because you're building and building, on top of that, and essentially the world stopped, cooperating. So whether you're dealing with urban environments, tree canopy, multipath, ports, unintended interference, the operational challenges now seem to be, even greater. So when you consider the work that you're doing and trying to take all that complexity, make it more simple, but in an environment in which those principles are even more important today. Can you walk us through how Trimble and Trimble Applanix think about that?
So trust is a word we talk about a lot within the organization, because ultimately that's what we're selling. That's what we are good at, and we have been good at for more than 30 years. Going back to the very early days, coming out of the aerospace and defense, you needed to know your data, your sensors were reliable. I mean, there was no opportunity for not having good data. We're not going to go down into too much technical detail, but going way back, there's this concept in sort of the aerospace vernacular called fault detection, isolation, reconfiguration. That was from day one, starting to develop commercial products. It was borrowing those kind of concepts, which we were very familiar with.
Sure.
So I think the trust, the integrity of the solutions have become far more critical. People are expecting that. If you go back, 20 years, 30 years, some of the mining companies that we have as our customers, they only had reliable satellites up in the air for a few hours.
Right.
Well, now some of them are operating, very large autonomous vehicles 24/7
Sure.
in difficult environments. So being able to trust that information is life critical.
Got it.
So when we look at products we're developing, we look at the data. We need to know the data that we're collecting is the best data that we can collect at the time. We need to be able to flag that data when it isn't.
Got it.
We need to be able to use our more complex sensor fusion engine to create the best navigation solution, position solution that we can at the time, based on the data we have available. And that has become somewhat easier because we now have so many more sensors.
Sure.
More complex from the algorithmic perspective, for sure. But certainly, as you alluded to, in some parts of the world, we get calls almost every day from customers saying, I'm operating in areas, my GNSS is jammed for most of the day. I can't fly. I can't do my hydrographic surveys. What am I going to do? So it's certainly become much more complex operational environment. And so those are the areas that I guess we're pushing the front on even more and more, operating with more sensor data, more compromised sensor data, but still being able to produce solutions that customers can use then to deliver that end.
So even in the service of integrity, that's more complex now.
For sure.
So yeah,
for sure.
And increasingly so. And if it's bad now, it's getting worse
right.
in terms of
yes.
how, in terms of just all those opportunities, whether it's naturally occurring stuff, scintillation, or intentional jamming, or just accidental interference. When you think about, we talk about, well, I can't operate right now, or I can't, or I'm getting jammed and I'm out of business today. If you're a capital project in the Mideast, let's say, and you're building a road, okay, the cost, the opportunity cost, the real cost associated with those project delays are just horrifying.
Absolutely.
The order of magnitude of the value that's being impacted by this is really significant, whether it's an offshore oil and gas, offshore, port, mining application, ag, or a construction project. The impact is really significant. This is not a casual problem.
Right.
This is a problem that is not just chronic. We've always known that, but it seems to be more acute now.
Agreed.
So, in the service of accuracy, I mean, and that's, let's focus on, because we're talking about the data quality, and we're talking about, how do you deliver that integrity, and what is that integrity? That's an expectation and a trust that Trimble, okay, a name people know and trust for many years, that if they're doing business with Trimble, they know they can trust that.
Absolutely.
Data. The complexity of that is significant. And so let's talk a little bit about that accuracy. And, if the data set's accurate, traceable, and trusted, what does that allow for? Because it seems kind of foundational. And if you've got the integrity and the accuracy and the precision at that level, everything else that you build on top of that, so too can be trusted. Can you talk to us a little bit about that? Maybe provide a counterfactual in terms of what it looked like if you didn't have that accuracy and that trust at the most foundational level.
So, moving on from the trust in the sensors you're flying or driving, knowing the data you collected is good or is certainly appropriately tagged, if not. So that's step one. But eventually now that data has to go somewhere. You can do a fair bit of additional data processing with edge computing technologies onboard the sensor suite itself. That's great. But at some point that data has to move into an ecosystem. Otherwise, the people in the mobile mapping van are the only ones that can touch it. Right? Ensuring that trust runs right through the lifetime of that data within that ecosystem. Because now you've got whoever's collected the data, putting it in, you've got surveyors using it, you've got construction folks using it, you've got project managers using it, you've got the end client potentially using it. Everybody needs to know that data, as it was collected, hasn't been modified, or if it has, it's properly tagged as to what has changed. If you can't trust that data, that information through the life cycle of the ecosystem, now you've got even a bigger problem, because as opposed to just a van full of people using the data, you've now got tens to hundreds of people using the data, and of course a magnitude, order of magnitude difference in the cost implication of that if the data is somehow lost that integrity.
Got it.
So when Trimble designs an ecosystem, Trimble Connect, for example, let's say, the foundational piece of that is the data integrity. You've got you got to go into how the database is set up, but you need to be very careful on who can touch that data and why. And if they do, where's the record showing exactly what's happened to that data? Because any change in the quality of that data, unintended, has to be categorized. If it happens without knowledge, that's a major blow to any ecosystem you're trying to get a customer to trust.
Sure.
There was a, I talked about this back at Intergeo, but there was a quote between us, which I really liked. Customers can compete on cost, but they can't compete on trust.
Indeed.
And that's just foundational. That is a fundamental piece that Trimble builds its business on.
And I think also that people, sometimes misunderstand, or they don't appreciate the value of, or the potential downside to what happens if you don't have data, trustable data, downstream, second and third order effect, the cascading effects of that lack of accuracy, lack of precision. And then you talk about data fidelity and chain of custody, and everything is auditable, and you provide that backdrop because that is the kind of focus on integrity. But I do recall the conversation that you and I had at Intergeo in Frankfurt, I believe. Yeah. And almost a year ago. But what we were talking about was this notion of, if you have, in the service of precision and understanding that your downstream customers and users, rely on that precision and that accuracy, but that data is going to be, and that creates the value and the quality of the data. But when you know you can rely on that, you can package that data and deliver that data through like Trimble Connect, or through, absorb it into the Trimble Business Center, and using Connect to basically get the right data sets to the right people in the field. And here's the qualifier: at the right time.
Right.
And when, and it's speed of what? Speed of decisioning, speed of accuracy. Think about all those, big projects out there right now. Out in the ocean, out in the desert, out in the major capital projects, time is critical.
Absolutely.
And so to be able to deliver the right data to the right people at the right time, and in fact, one of your colleagues from the geospatial side is saying, that's an accuracy chain, the right data at the right time. And if you think about that, it just seems that the standard and the requirement for integrity is getting, is super critical, and that you wouldn't be able to do those things but for that intense focus.
And I think it goes back to what's driving that partly is the speed. Right?
Yeah.
Everybody is trying to do things, bigger things, trying to do it faster. And so you've now got more people involved in the chain of decision making. Again, you've got to know that data that the decisions are being made on is correct. So these large projects that go on, in any city you go to now, there's construction all over the place. You know how long construction tends to take. As you said, time is money. So getting those projects to completion faster, correctly, first time, just absolutely critical.
Yeah, and in the idea with time is money, I'm reminded, Steve, that the poll questions are going to close at the bottom of the hour. So you have just another minute or two to please answer the questions that have been posed through the chat. I am sure they appreciate Trimble Applanix appreciates that. We appreciate that. We like the feedback loop. We want to hear from you, and so I encourage you to provide that input. Well, that's the right data, right? Talking about data life cycle, right? You can't even talk about the concept of a data life cycle without having all that work for decades to prepare yourself, your data, your sensors, your integration, your algorithms, all kind of in the service of data life cycle. I just find that really interesting. And so I want to talk to you now. I want to shift the focus a little bit, to something, that we kind of know and love, and it's, in the service of that accuracy, and that is, corrections. So, are corrections and processing becoming part of the positioning architecture itself, rather than this kind of, separate service that you would kind of this add-on? It seemed that there was this kind of, it lived in a separate world. And I think, Trimble and Trimble Applanix has done a lot to integrate the corrections at a really foundational level. And I'm not just talking about, tightly coupled, going from a loosely coupled to a tightly coupled to a deeply coupled, integration. I'm talking about, thinking differently about how those corrections are ingested, right, and how they're kind of consumed. Can you kind of walk us through the current thinking on corrections and its contribution to integrity?
So corrections to some extent are almost like another sensor input, right?
Sure.
But now it's a sensor which you don't have on your vehicle.
Yeah.
So you've got to now rely on that. So Centerpoint RTX, in the post-processing world, we use PPRTX, so still based on the same technology, but in a post-processing environment. There are, of course, many correction services out there. One of the things we did on the Trimble RTX one some time ago now was, again, going back to this concept of trust and integrity. It's actually not that difficult to spoof a correction service. So in order to make sure that we know the corrections we're getting are correct, we have built in integrity into those correction signals as well. So sure, we know that what's coming in is a verified correction signal. We know that we can use it. We can trust its accuracy, again, or not, depending on where we are. So while we focus an awful lot in the RTX world on larger worldwide coverage, expanding the fast region that we operate in, so the convergence is faster. Sure. We've spent probably an equal amount of time on making sure that those signals, again, back to this concept, the customer can trust that those signals coming in. It's been an interesting shift over the years, and it's been slower than I might have thought it would be. The move from customers setting up their own base stations or using some sort of local correction service or base station service to
like
working,
a cores, you mean?
Like a cores,
sure.
To going to something like an RTX system. We've seen customers coming off systems like cores a little more frequently, understanding the value that RTX offers. Again, back to the integrity, the availability, the accuracy. What surprised me a little bit was not everybody wants to give up their own base stations. So this idea of setting up your base station and going and typically flying it, a UAV, because you got to be fairly local. Yep. People just still really like to do that. And I've talked to so many people. I said, have you ever come back to your base station to find it's not there? I said, yeah, well, it happens occasionally. But again, it's a workflow that they're used to, they trust.
That's it.
And then trying to get them to move to something different is a process. And I get that because
sure,
you know how to deliver the end result.
Sure.
So we are seeing movement in that direction, but slower than certainly slower than I thought might happen.
Sure. Well, it's always a challenge to, people get comfortable with workflows, and this is the way we've done it. And this is, we do. And there is some wisdom in that, insofar as, look, this is, we're creatures of habit. We're good at it. And this is our process.
And it works. And
Yeah.
and for certain applications, certain types of surveys, it works really well.
Yeah. Yeah. But, so, and I think where I want to take the conversation, though, is to kind of characterize and describe the extent to which Trimble is continuing to innovate, not just in terms of, corrections integration, not just RTK or center point RTK, then the evolution of RTX, how it's become kind of more fully integrated into, like in APX, 20, and then kind of as the highest form factor of that, or the highest expression of innovation, now even in the business model, in which you've got a subscription opportunity that perhaps can address some of the challenges of, we're comfortable of doing it this way, and maybe there's a cost consideration. But this, you introduced the subscription at Intergeo last year.
Mm-hmm.
Talk to us about that, because I find that fascinating.
That was an interesting process. We spent about 18 months interviewing customers, coming up with ideas, talking to the customers, having focus groups about what a subscription, not software now, but a subscription hardware married to the software would look like. And one of the things we've heard many times is that somebody goes out to do a job, they've got an accuracy spec they're trying to deliver to.
Sure.
And sometimes it's, sometimes it's 20 centimeters, sometimes it's 2 centimeters. But if you're going to be able to bid on all the jobs, you have to have the whole suite of tools available to you. But can't necessarily justify buying an all singing, all dancing, correction, a positioning system for your whole business. So with the feedback we've been getting over the years, we sort of propose this concept that basically you have a
right,
and then you pay for sort of as you use it, you need, and you can get corrections or get higher accuracy out of the sensors you're using. You can go into a job and deliver 5 centimeter accuracy one day. The next day you're just doing sort of a wide area, general look at what's going on. And we got customers really engaged in that. And with the back and forth, we've sort of massaged the model on what we think makes sense. And we sort of have two camps right now. We've got what I would call, let's say, sort of the newer customers.
Mm-hmm.
I don't mean more progressive in any sense, but newer customers to Trimble, to the business, without necessarily having played in the geospatial market for a long time. I'm thinking some of the UAV, the drone operators.
Sure.
They think this is great.
Look, I mean, it was just not too long ago that UAS kind of discovered RTK,
right?
A match made in heaven,
right?
10 years ago, who knew, right?
Yeah.
So markets like that, and what that is, you're seeing demand signals from these kind of emerging new markets. So that's pretty darn exciting.
Absolutely.
Yet another good reason to innovate. But please continue.
And these folks don't necessarily have 20 years of geospatial background in them, or a suite full of geospatial experts on staff. So again, they need to understand how it works enough to be able to make it work. They need to know the data is good. They need to know they can trust the data. But they're far more interested in their business, how they can deliver what they need to in their business. And then this idea of a flexible business model has really resonated well. So we've had groups of customers that think this is just fantastic, and some it's still it's a work in progress.
Well, I mean, the bottom line is, that flexibility, you can serve the needs of all. The thing that I find kind of fascinating that I'm thinking about is, if you're a current Trimble customer, I'm thinking of a contractor out there, and they have this ability to suddenly have better, capability, deliver, depending on the project, might they then have the ability to go out and bid on larger, different, a more diverse set of projects? And I mean, do you see that happening?
That's exactly, and that was what drove this. The customers come to us and said, we don't want to buy the really big system because we'd only use it 10% of the time, but we want to be able to have the capability to do it because it expands.
Or we think we do, we're not sure. And we might test this and we might say, oh, by the way, and when you think about that, it's also an on-ramp to more sophisticated systems, right. Sophisticated in that they're expensive, they're more complex, and maybe they don't feel comfortable using them. And that's going back to your ground, your ground station kind of, comment. But the idea that they can then compete at a different level of scale, right, and complexity helps grow their business, develop new capabilities and expertise such that they may then focus on that and end up buying, robotic total stations or whatever, right?
Right.
So
and that was basically the feedback, right?
It.
We want to be able to expand what we can go after with our business, not just be limited to one particular area. And so those that kind of have that business mindset have really taken to this new concept.
Yeah, and so you know what? Here it comes back to the customer again, right? I mean, that's really what that is. And what you've done is you've created this kind of highly variable, flexible, bespoke solution that every customer, current and future Trimble customer, can bring to bear in a way that's going to add accuracy, precision, robustness, integrity for not. It seems the incremental value versus incremental cost is huge.
Right.
Yeah. So in speaking with the customer, let's bring it back to the customer, the contractor. What if I'm a contractor and I'm out there listening, taking everything that we've talked about so far, Steve, synthesize that, distill it down to some essential, points of value. How do you see, you having the ability to create value for the contractor's workflow? What is the currency? Is it less rework? Is it, faster execution? Is it better? Tell me about all the various layers of benefit or where you think that simplifying a lot of that complexity really, expresses itself in your customers' real, daily lives and daily workflow.
Simplifying the complexity, I think, is absolutely critical, so that you have a wider audience that can use it. I think that this concept of sensor fusion, bringing all of these sensors back in to produce the solution, data quality, data trust, absolutely critical. Again, for what we're offering. We've talked already about the cost of rework. I mean, cost of rework is huge. A single surveyor, okay, not great, but you think about a survey vessel that's has to be docked at the harbor.
Sure.
Has to go back out and resurvey. There's a lot of zeros that go along with that particular job. I think one of the things we should talk a little bit about before we go to the questions here, because you can't really have a conversation at the moment without bringing it into the discussion.
2 letters.
2 letters.
AI.
You got it.
Yeah. So we wouldn't be having a discussion in 2026 without talking about AI and its role. So please tell us how.
So Trimble's using AI in a number of ways. Yes, we're
Sure.
using internally for software development or work on producing product requirement specs, that sort of thing. We also have a number of AI agents in our products, things that can help, let's say, feature or help the process workflow. If a customer gets stuck, what do I do next? What should I do next? One of the things that we're finding, and I'm talking more about Trimble Applanix, is one of the things I think that is really critical is the amount of data that is owned by or Trimble has the access to.
Sure.
We recently acquired a company, Document Crunch, and it's got, many, many years of history of managing documents.
Sure.
In our case, we have thousands upon thousands of UAV flights in some very difficult areas all around the world at different times. That data, to be able to train AI engines, now to be able to move the AI capability back into your products at a core sensor fusion level, or at a data exclusion, looking at how you toss data out, again, back to that integrity. This is where I start to get excited about it, because
so you're using AI to kind of identify bad data sets, as an example,
right,
one,
right.
And then you're taking a whole kind of 30, 40 plus year, you got these massive archives of data sets, and you're using those data sets to train AI, so that you then have, you're essentially improving the quality of the data moving forward based on the historical kind of archival data sets that you have.
That's exactly it. Exactly.
The fact that it's Trimble, I mean, that puts you in a really unique position. It's like, oh, by the way, remember all those data sets that were in the dusty archives? And guess what? There is gold in them hills, right? And so tell us more about how you see the value of that, because and I'm thinking, again, in the service of accuracy and integrity and those that data quality, because it seems that data quality is becoming the currency, and you're using AI to improve not only the value but the quality of that currency. Can you talk about that?
So you think about the concept of physical AI. It's AI that happens at the sensor level, or at the real world level.
Sure.
AI is doing sensing, it's doing reasoning, it's acting somewhere. It's not simply within a software environment.
Sure.
So being able to take all of that historical data, being able to train the sensor fusion engine on that historical data, look at how you're producing your navigation solution, how you're producing your trajectory solution. You can now use the last 30 years of learning to be able to improve that, which means that often you can now use less expensive sensors, because you can now actually squeeze more performance out of those sensors.
Sure.
So you wind up with a less expensive product in the end, producing far better quality. And again, back to this concept of trusted data. So this is still pretty early days from AI in the sensor fusion. There's lots of technical papers out there. In any technical conference you go to, you'll see lots of papers. But looking at the work we're doing today, it is pretty exciting. Some of the early results we're seeing here that not in products yet, but I think could have a significant impact on products going forward. And
Indeed.
I think the companies that have access to that kind of data are the companies that are easily going to win this game.
Yeah, no doubt about that. And I would add this kind of what used to be kind of a parallel and fairly well aligned technology is now directly intersecting, and that's autonomy and autonomous operations being enabled. And because by definition, those systems tend to be further out and used in the tactical edge, and so you're collecting all that data, detailed data. Many believe that the vast majority of the real value and the highest value is that within the 2-3 centimeters accuracy. So if you think about that, when you're collecting data out there, whether it's for in the service of a physical AI, digital twin, think about that gets really exciting. Because you have, you take that data and that is the kind of foundational raw material that physical AI needs to ingest to kind of build its models.
Mm-hmm.
So that's really exciting kind of high concept, but nonetheless, it all comes back to precision, accuracy, and integrity in that gives you the high quality data, without which
that's the bottom line.
You've got a robot in an alley, stuck. Let's get to poll results. That's a fascinating conversation, Steve. I always appreciate your time and your perspective, and boy, it's exciting days right now in our various kind of industries. But I do want to share the poll results with our audience. And so the first poll was, what's the primary technical roadblock currently impacting your team's field to finish throughput? And the highest level of response was 50%, indicating that base station dependency and GNSS denied jammed environments.
There we go.
Second, and tied, both at 20%, sensor fusion and alignment across multi-sensor payloads.
Right.
One. And manual quality, QA, QC, quality assurance, quality control, and feature extraction delays. Maybe speaks to some AI
for sure
capability.
Yep.
And then lastly was post-processing. So it seems that the all your work on the post-processing seems to have kind of taken effect.
Well, that's good news.
Yeah. So base station dependency and GNSS denied jammed environments. How does that comport with your earlier statement about, you think about it, is there a change in the air? What do you think about that data?
Yeah, I mean, I'm not surprised.
Yeah.
Again, we talked about the base station dependency. We've talked about reliance on, or trying to get reliance on things like correction services, Centerpoint RTX. GNSS denied, 4 or 5 years ago, it was a topic of conversation sort of in certain corners. Now it is a broad topic. I would say we get a dozen calls a week from customers, from clients who aren't customers yet. How can we solve this problem? Here's my problem. Here's what I'm operating in. What can you do for me? And that's great, because I want people to be able to come to the folks who work at Trimble Applanix as the industry experts, to be able to have that discussion, so we can inform you with our expertise on what we think might work, might not work. And we've always said, we'd really love you to buy Trimble products, but we also want you to see us as a resource, so that we can help educate you. And we do a lot of work when a customer buys a product from us on the integration into their system, because it's always a integration workflow. And that's something I think that we've gotten very good at over the years.
Yeah, and I think, having attended more than a couple of Trimble Dimensions, I can attest to that, because 35, 40, 50% of the sessions there are how to optimize the use of the instruments and the gear and the equipment that they currently have. So yeah, I know that's a huge commitment by Trimble.
So that's a great outcome. And as you said, I'm really happy to see post-processing at the bottom.
There you go. We solved that one, right? Let's continue. The next poll question was looking at next generation positioning. Which emerging technology do you expect to have the biggest impact on your operations over the next 3 to 5 years? First one, I'm not going to, the first was cloud-based direct georeferencing, processing as a service. The thing that we were talking about earlier. Third, tight sensor fusion, combining GNSS, INS, SLAM, maybe with visual odometry. And then lastly, AI-driven automated data extraction. And what we found was tight sensor fusion. 71%.
Wow.
71%. Combining GNSS, inertial, SLAM, and visual odometry.
Right.
What's that telling you?
So I think that's very
You're in the right business. Is that what it's telling you?
Yeah, very, very consistent with our approach here. Is that, again, many of the sensors have become much less expensive.
Sure.
We're able to produce a much better solution using, again, multi-sensor integration, the sensor fusion concept. And so many of these vehicles already have cameras and LiDARs on them to collect data. Why can't we use them to improve the positioning solution as well? So again, that's been a huge topic of conversation now this isn't new. This goes back to 2015, 2016. And And so we have more and more products coming out. We really didn't have time to talk much about things like LiDAR QC or camera QC.
Sure.
But these tools are using a lot of this technology to help improve that positioning
Sure.
solution.
Yeah, no doubt. And the fact that you have those data sets and the quality, and those data sets really enable you to have future technical leverage and continue to capture all the adjacent data is pretty exciting. Next question, the last question on the poll was, what is currently your biggest operational bottleneck in mobile mapping deployment? That's a good question.
I'll say, yeah.
Third, massive, increasingly so, right? And registration slowdowns. And then integration costs across multiple sensor platforms. GNSS denied was 38%, highest. Second was point cloud density, tied with, not surprisingly, massive data processing. They kind of go hand in hand.
Right.
And then, you'll be pleased to hear that the last consideration was integration costs across multi-sensor platforms. What does that kind of hierarchy, the rank order of that feedback tell you? What does that indicate to you, Steve?
So I was wondering if denied was going to make the top of the list.
There you go.
I figured it might be close, but consistent with what we've been talking about, for our listeners, clearly it made it. I think, again, going back to this AI topic, we talked a little bit about those massive amounts of data, LiDAR data, camera data, being able to use edge computing in the actual sensors themselves. The sensor fusion engine can help with a lot of that data. The massive amount of LiDAR data being processed, again, if that can be cleaned at the sensor level,
there you go.
You can process less data. You don't necessarily need all the data that you've collected to do the job you need to do. So you don't necessarily need to load it all up to the cloud, but if you can do some more intelligent segmentation, if you will, at the sensor level, at the collection level, that will help. That will help ease, I think, the processing somewhat. But there's no doubt this is going to be a problem for a while to come. Yeah.
So if customers or future customers would like to get more information and kind of continue this conversation, you have both websites and a live event, I understand, coming up. Could you tell our listeners about that?
We've got two big things happening here in the next little bit. So InterGeo, which is happening in about a month.
Sure. We'll be there.
We have some really exciting announcements coming from Trimble at InterGeo.
Okay.
Now, I can't say anything more than that, but I believe this is going to fundamentally move the ability to produce good data.
Okay.
So,
in service of high quality data.
In service of high quality data that you can rely on. So
nice.
So stay tuned. If you're in InterGeo, outstanding. You need to come talk to us. If not, look for the announcements. The other big one I talk about is our European UGM, user group meeting.
Okay.
We had our North American user group meeting here in Toronto about a year ago. This will be our first users group meeting in Europe since 2018.
Okay.
COVID, of course, got in the way of our long-term plans.
And where's that going to be held, Steve?
It's going to be held in Prague.
Oh,
it's going to be
nice.
held December 1st to the 3rd. We've got 12 industry speakers, and coming off of our last UGM, the speaker session is, to me, by far the most interesting. We get to hear tremendous stories from you, the customers. We're also going to have on the order of 20 Trimble staff there from multiple divisions, from OEM GNSS, from Applanix, from TAP. The Marine folks are going to be there.
Wow.
You're going to have technical folks. You're going to have leadership folks. It is always a fantastic event, and we're really looking forward to hosting this event.
Oh, fantastic. Well, that's all the I want to thank everybody for joining us today. Steve, it's always, and we appreciate your insight and your time. And until we see you next time, I am Richard Fischer at xyHt and Steve Woolven. Have a good day.
Thank you all, and thank you, Richard.